let's review the mesh quality. Before that, if I highlight mesh and go to statistics, I see that I have around 27,000 elements, that is cells in the finite volume method, or around 27,000 control volumes. And at the center of each cells, the flow variables will be calculated. So essentially what we have marked out are the locations at which we want it to calculate the flow variables. And we have also told it which, when writing the control volume balance for this cell, which neighboring values to use, the so-called connectivity information. Let's take a look at the orthogonal quality of the mesh, and we'll see what that is in a second. So go to mesh metric, orthogonal quality. And 1 is good, close to 1 is good. So let's take a look at the cells that have good orthogonal quality, and you see that the adjacent faces or edges are at nearly 90 degrees. And if it's 90 degrees, it's perfectly orthogonal if adjacent sides. Let's look at this cell which has poor orthogonality. So let me zoom out here and highlight that. And you can see that's right at the trailing edge. And if I zoom in, I can see the skewing. So the adjacent faces, for instance, are quite a bit away from 90 degrees. And you can imagine writing, conservation of mass and conservation of momentum for that type of a cell. You would get a high error for those particular cells. At the trailing edge, for this unstructured irregular mesh, it can be hard to fix these. You have to go to, you have to divide the domain up and so on. But that's something to keep in mind. We don't have a lot of cells that have poor orthogonality, but they are located at the trailing edge, which is a very important region. The other measure of quality to look at is the aspect ratio. So if I go and select aspect ratio, and if I look at the ones that are close to 1, aspect ratio close to 1, and let me zoom out, I can see that these have this length is similar to that length. Let's look at the cells that have a high aspect ratio, and this can be hard to select. So I can go to controls and say show aspect ratio. So let me move this here, and I'll say show me, I'll say 20 cells, and I can play around with the axis, and maybe that should do it. Okay, so now I can select the high aspect ratio cells, and you see it's the same ones again. And then what about these? So let me zoom out here to see those. And you can see it's these in the region near the surface. And near the surface, I'm going to get gradients, high gradients in this direction, perpendicular to the surface, than along the surface. And so this is okay in the boundary layer area. Otherwise, you would want to avoid those high aspect ratio cells if the gradients in either direction are similar. So those are a couple of mesh metrics to look at. And if you have a lot of cells that have poor aspect ratio or orthogonality, that can be a major issue, and it can take time to fix these things. Okay, so I'll exit. I'll just say I'll clean up here, and I'll just go back to my front view.